Assalamu alaikum. Welcome to Telikilaas. I hope you remember what we have been discussing throughout these lessons, because today's topic is the continuation of what we have been discussing, which is transformation. Before moving on to today's topic, let's recall what we have been learning under transformation. By now you should know in your syllabus you have to deal with 4 types of transformations, that is translation, reflection, rotation and enlargement. Out of the 4 types, we have already discussed the first 3 types of transformations, which is translation. Translation is the sliding of an object by a given vector. The vector will show you the information about the movement, whether to move the object to the right, to the left, up or down. The second type of transformation we have discussed is reflection. Reflection is the flipping of an object from a fixed line, and this line is called the mirror line or line of reflection. And the third type of transformation we have discussed is rotation. From the name itself we know what rotation is. It is the turning of an object from a fixed point, and you should know, in rotation you should know the angle of rotation and the direction of rotation as well. In today's class we are going to discuss the 4th type of transformation, which is enlargement. By the end of today's class you should be able to draw enlargements, you should be able to recognize and describe enlargements as well. Now first let us see the meaning of enlargement and what it means to enlarge something in mathematics. From the word itself, I am sure you have some idea about what we are going to learn today. Enlargements. The meaning of the word enlargement is making something bigger. If we look at a mathematical definition for enlargement, enlargement is a type of transformation that changes the size of an object. So in math, enlargement is the transformation where the size of the object changes. Now we have already discussed translation, reflection and rotation. For these 3 types of transformation, we have seen that the size of the object stayed the same, it did not change. So enlargement is the only type of transformation where the size of the object changes. It says the object stays the same, but the size changes. Here the object stays the same means the general shape of the object will be the same. If you are given a rectangle, the enlargement of it will be a rectangle, the shape will be the same, only its size is going to change. Sometimes when we enlarge a shape, the size of the object gets smaller. Now here this point, many students have the misconception that enlargement is making something bigger, but in mathematics the word enlargement means we are going to change the size of it. That change can be anything, whether the size is going to get smaller or bigger. And to enlarge a shape, a scale factor and a center of enlargement is required. Scale factor we will discuss in detail, and here center of enlargement means it is the point from which an object is enlarged. Likewise in rotation we had center of rotation, which means it is the fixed point from which we have rotated our object. Likewise center of enlargement means it is the point from which we are going to enlarge our object. The center of enlargement will show you where your enlargement is going to be. Now let's see what a scale factor is. Scale factor is the multiplier that tells you how much one shape is larger than another. In other words, if we describe a scale factor is the size of enlargement, it will tell you how many times your object is going to be bigger or going to be smaller. The scale factor can be positive, negative, or it can be a whole number, even a fraction as well. If the scale factor is greater than 1, then it enlarges the object. Now if your scale factor is smaller than 1 here means it has to be a fraction less than 1. If you have a scale factor less than 1, a fraction, then it will reduce the size of the object. For example, if you have a scale factor 2, means the enlargement will be twice bigger than the object. Likewise, if you have a scale factor 3, your enlargement will be 3 times bigger than the object. Now if you have a scale factor half is 0.5, which means it is a value less than 1, and it is a fraction as well. So the size of enlargement will be smaller than the object. How much it will be smaller? Your enlargement will be half the size of the object. Now we have positive and negative scale factors. This part is very important for extended students, because in extended we have both the scale factors positive and negative, but if you are taking core syllabus you have to deal with only positive scale factors. Now let's see the difference between positive and negative scale factors. Here also many students think that negative scale factor means the size of the object is going to get smaller. That is not what is happening here. Negative doesn't mean the object will get smaller. Now let's see the difference between positive and negative scale factors. If you have a positive scale factor, then object and enlargement will appear on the same side of the center of enlargement. So from the center of enlargement, your object and image will be on the same side. But if you have a negative scale factor, then your enlargement will appear on the other side. That means your enlargement will appear on the opposite side of the center of enlargement. This means if you have a negative scale factor, object and enlargement will be on opposite sides of the center of enlargement. If you have a positive scale factor, object and enlargement will be in the same orientation. This means your object and image will be in the same direction. But if you have a negative scale factor, your enlargement will be inverted. Inverted means upside down. So if you have a negative scale factor, your object and image, your image will look like that it has rotated 180 degrees. Now what will be the difference here? If you have a scale factor of 2 and if you have a scale factor of negative 2, what do you think? What will be the difference between these two scale factors? Now if you look at the two scale factors, we have the same value, but the sign is different. We have a positive 2 and a negative 2. Now let's see what is the difference if you have the same value but with opposite signs in it. If your scale factor 2 means positive 2, likewise we have discussed here triangle ABC is the object and this is the enlargement, that's the image. So if you have a positive scale factor, now scale factor 2 means your enlargement will be twice bigger than the object. As you can see here, object enlargement is twice bigger. Here O is the center of enlargement. You can see both the object and image are in the same side of the center of enlargement, which is the right side. It's on both the object and image are on the same side, and their orientation is also the same. Both the object and the image are in the same direction. Now let's see how this will be different if you have a negative scale factor but the value is still the same. Negative 2. Now ignore the negative sign. 2 indicates the scale factor value will indicate you how many times your enlargement will be bigger. So since we have 2, here also your enlargement will be twice bigger than the object. Now look how this is different from our previous one. Since we are having a negative 2, our image is on the opposite side of the center of enlargement. Here is the center of enlargement, image is here. As you can see, the object appears on the opposite side of the center of enlargement, and if we look at the orientation of the object and the image, as you can see, the image has been inverted. It is upside down. Looks like our object has been rotated 180 degrees. So that is the difference between positive and negative scale factors. Now in this part we are going to discuss how to draw enlargements. As we have discussed earlier, in enlargements there are two pieces of information which are very important. One is the center of enlargement and the second one is the scale factor. So I hope now you understand what a scale factor is and what is the center of enlargement. Now look at an example here. It says enlarge this object by scale factor 2. So we are going to enlarge the rectangle here by the scale factor 2. If you look at the question here, we know the scale factor but the center of enlargement is not given. So the scale factor will tell you how many times your enlargement is bigger, and the center of enlargement tells you the position of the enlargement. Since we don't have the center of enlargement here, you can draw your enlargement anywhere on the grid. It will be correct because we don't know where it is going to be since the center of enlargement is not given. So the only information we know here is we have to enlarge this one by scale factor 2. So no matter where you draw the enlargement, enlarge it by scale factor 2. How to enlarge this one is, we know that our image, our enlargement will be twice bigger since the scale factor is 2. How to draw the enlargement is, we identify a side of the object. You can take any side of the object, check the distance of the side. Now if you take the side here, the distance of this side or the length of this side is 2 squares. Now what is the scale factor? Scale factor is 2. So we are going to enlarge this side twice. Twice means this side has to be 2 times bigger. So to get the correct distance of the enlargement, what we do is we multiply the distance by the scale factor. Scale factor is 2. So since our length of this side is 2 squares, multiply it by 2. 2 times 2 is 4. That means the same length of the enlargement will be of length 4 squares. So you can draw the same side on the grid. Anywhere you can draw, since the center is not given. So the same side of the enlargement will have 4 squares the same way. And again you can take another side. So if we take this side, the length of this side is 3 squares. So we are going to enlarge the same side by scale factor 2. So multiply the length by scale factor 2. 3 times 2 will give you 6. That means the same side of the enlargement will have 6 squares in it. So you can draw the same side of length 6 squares. Now you can fill the remaining sides of the shape because it's a rectangle with these 4 squares, and height we have 6 squares. Okay, now look at another example. Here in this example we have to enlarge the triangle given here by the scale factor 3. Here also the center of enlargement is not given, so it doesn't matter where you draw your enlargement, but you have to enlarge the triangle by scale factor 3, meaning your enlargement will be 3 times bigger than the object. Now the same, we are going to follow the same steps. Identify a side of the shape and find the length. Here if we take this side of the triangle, the length of the side is 2 squares. So we are going to multiply this by the scale factor. Here the scale factor is 3, so multiply it by 3 to get the length of the same side on the enlargement. 2 times 3 is 6. So the corresponding side of the enlargement will have 6 squares. So you can write, so you can draw the same side with 6 squares. Now check another side. If we look at the base of the triangle, the length of the base has 2 squares again, multiplying it by the scale factor, which is 3. 2 times 3 again gives you 6. So the base of the enlargement will have 6 squares in it. So you can draw the base of length 6 squares, and then you can fill in the remaining side. So that is the enlargement of the triangle with by the scale factor 3. Now in the next example it says enlarge the given rectangle by the scale factor 3 from center 0, 0. Here in this example you are given both the scale factor and the center of enlargement. So your enlargement has to be in the correct position and in the correct size. How to draw enlargements when you are given both the scale factor and center of enlargement is, as the first step we are going to identify the center of enlargement. Here the center is 0, 0. So on the grid plot the point 0, 0. 0, 0 is our origin here. So you can plot the center of enlargement 0, 0, and after identifying the center of enlargement we are going to draw straight lines from the center of enlargement through all the vertices of the object. All the vertices means it's the corners of the object. You have to draw straight lines from the center of enlargement through all the corners of the object. Here our object is a rectangle. A rectangle has 4 corners, so we are going to draw 4 straight lines through all the 4 vertices. Now you have to be very accurate when drawing these lines. So from the center of enlargement draw straight lines through the vertices same way. Make sure you use a ruler when you draw these straight lines. So from the 4 vertices we have drawn straight lines from the center of enlargement. Now here these straight lines are also called ray lines. That is our second step. First step was identifying the center of enlargement. Second step is from the center of enlargement we draw straight lines through all the vertices of the object. Now the third step is find the distance from the center of enlargement to a vertex. To a vertex means to one corner we have to find the distance from the center of enlargement. So here I am going to identify one point on the object, that is the left bottom corner of the object. Now from the center of enlargement to this point we are going to find the distance. The distance you can take in two ways, diagonally, that is the straight distance you can take, or you can take the root, the translation vector as well. What I am going to do here is I am going to find the translation vector, that means the root from the center of enlargement to the point here. So the distance from the center to that point we have across 1 and up 2 squares, that is the distance. After identifying the distance, now our next step is multiplying the distance by the scale factor to find the distance of the same vertex in the image. Now this means we have identified the distance from the center of enlargement to the point here. The distance was 1 square across and up we have 2 squares. Now we have to multiply these distances by the scale factor. Our scale factor is 3, which means enlargement will be 3 times bigger than the object. So multiply these distances by the scale factor, 1 multiplied by 3 and 2 multiplied by 3. Now this means the same point on the enlargement will have the distance 3 squares across and 6 squares up from the center of enlargement, because 1 times 3 is 3, 2 times 3 will give you 6. So we are going to draw the same point. Now we know where it will be. From the center of enlargement, 3 squares across and 6 squares up. So this is the same point on the enlargement. So we have seen when we enlarge this point by the scale factor 3, the point is here. Here is the same point on the enlargement. As you can see, both the points lie on the same straight line we have drawn. That is the use of these ray lines. Your corresponding points has to lie on the same line. Now there is one other way where we can find the same point on the enlargement. That is the same way we have found from the center of enlargement to the point. You can check the distance, which is 1 square across, 2 squares up. So what we have to do here is, if the scale factor is 3, we are going to take the same distance 3 times. So across 1, 2 up. Again, second time we can take the same distance, and third time. As you can see, the point is the same there. So that is also one way where you can take the scale factor 3. Now we are going to check the position of this point on the enlargement. The same way we are going to find the distance from the center of enlargement to the point here. As you can see, it is 1 square across and 3 squares up. 1 across, 3 up. So to get the same point, that is the corresponding point on the enlargement, what we are going to do is we are going to multiply the distance by the scale factor. Our scale factor is 3. So multiply it by 3 to get the distance of the same point from the center here. So as you can see, the same point of the enlargement will be across 3 squares, because 1 times 3 is 3, and up you will have 9 squares now. 3 times 3 gives you 9. So the same point on the enlargement, 3 squares across and 9 squares up. This is where the corresponding point on the enlargement is going to be. Now we are going to follow the same method to get the remaining points on the enlargement. Likewise, identify a point, check the distance. Here the distance is across 3, up 2 squares, multiply it by the scale factor. Here scale factor is 3. So across 3, if you multiply 3 by 3, it is 9. So across you will have 9 squares, and to this point vertically we have 2 squares. 2 multiplied by 3 is 6. So the same point on the image will be 6 squares up. So this is the point on the enlargement, the same point on the enlargement. Now since it is a rectangle, no need to find the remaining vertex. So you can fill the sides of the rectangle by joining the points you have drawn. So this is the enlargement of the rectangle by scale factor 3. Now to check if your enlargement is correct, you can check all the corresponding points. Corresponding points means if you look at the point here, this point on the image is here. So these corresponding points should lie on the same ray line that you have drawn at the beginning. So check if the corresponding points are on the same straight line. As you can see, all the corresponding points lie on the same ray line here. And to check if your drawing is correct, we have enlarged this rectangle by scale factor 3. To check if it is correct, take one side of the shape. I'm going to take the length of the rectangle here. The length of the rectangle has 2 squares. So if we are enlarging this side by scale factor 3, it has to be 3 times bigger. So multiply this value by 3. Now 2 times 3 is 6. So the same side on the enlargement must have 6 squares in it. As you can see in your enlargement length, we have 6 squares. Likewise, this length on the object, we have 1 square. Now if we are enlarging this side 3 times bigger, 1 multiplied by 3 is 3. As you can see, we have 3 squares in the enlargement. So this is the enlargement by scale factor 3. Here we have another example where we have to enlarge the given triangle by scale factor 2 from center 2,1. Here also you are given the scale factor and the center of enlargement as well. So the position of the enlargement has to be correct and the size of the enlargement as well. Now we are going to follow the same steps to enlarge this triangle. Our first step was identifying the center of enlargement. Here center is 2,1. So identify 2,1 from the grid. 2,1 means x coordinate is 2. Here x value is 2 and y coordinate is 1. From 2, y value 1 is here. So this is our center of enlargement. Mark the point. And as the second step, what we did was from the center of enlargement through all the vertices of the object, we draw straight lines. So since it's a triangle, we have 3 vertices in the triangle. We are going to draw 3 straight lines from the center through these 3 points. So those are the ray lines from the center of enlargement. Now as the third step, what we did was identify one vertex or one corner on the object. Check the distance from the center of enlargement to that point. So as you can see here, from the center to the point, we have across 1 and vertically also 1 square. 1. Now since we are going to enlarge this triangle by scale factor 2, this distance we are going to multiply by 2. Now this means the corresponding point on the image, on the enlargement, will have 2 squares across and 2 squares vertically as well, because we get the same value there. So the same point on the enlargement, 2 squares across, 2 squares up. So this is where the corresponding point on the enlargement is going to be. Now we are going to follow the same process to get the remaining corners of the shape. Identify another point or another corner. Check the distance from the center of enlargement. From the center of enlargement to this point, we have across 1 and vertically we have 4 squares. Now multiply this distance by the scale factor, which is 2. So the same point on the image will have the distance from the center across 2 squares, and vertically we will have 8 because 4 multiplied by 2 is 8. Now draw the same point on the enlargement across 2 and vertically 8 squares. So this is the same point on the enlargement. Now the same way, the third point, check the distance from the center of enlargement to the point there. Now if you can see we have across 3, up 1. Now multiply it by the scale factor 2. If you have across 3, multiplying it by 2 will give you 6. So across 6 squares, and then since vertically we have 1 square, 1 multiplied by 2 is 2. So across 6, vertically 2 squares. This is the same point on the enlargement. Now you can join the points to fill in the shape. Now that is the enlargement of the triangle by scale factor 2. Now like we have discussed, you can check if your enlargement is correct, check if the corresponding points are on the same ray line, and you can take any side of the shape. If you can check the base of the triangle, we have 2 squares. So if you are enlarging this by scale factor 2, 2 multiplied by 2 is how much? 4. So the same side of the enlargement must have 4 squares in it. As you can see, we have 4 squares. Now here is an example where you have a scale factor less than 1, as we have discussed before. And if you have a scale factor less than 1, and if you have a fraction, that means your image or your enlargement will be smaller than the object. Here you have to enlarge the given triangle by the scale factor 1 by 2 from center 0, 0. 1 by 2 means it's half, so your enlargement will be half the size of the object. Now again we are going to follow the same steps. Identify the center of enlargement. Here center is 0, 0. So that is the origin. Plot the point. From the center of enlargement, draw the ray lines through all the vertices and identify a vertex on the object. Check the distance from the center of enlargement to that point. If you take the point here, as you can see, the distance from the center of enlargement to that point, we have across 4 squares and vertically we have 2 squares. So across we have 4, vertically 2. Now the same way you multiply these distances by the scale factor. This time our scale factor is half. So multiply the values by half. It will give you the distance of the same point from the center to the enlargement. So 4 multiplied by half is 2. That means the same point on the enlargement will be across 2 squares from the center. 2 squares across, and 2 multiplied by half is 1. So vertically you will have 1 square. So this is the same point on the enlargement. Now follow the same steps. Identify another vertex on the object. Check the distance from the center of enlargement to that point. As you can see, from the center to the point here we have across 4 squares and vertically we have 5 squares. Now you have to multiply the distance by the scale factor. Our scale factor is half. If you have across 4 squares, multiply it by half. Again, 4 times half is 2. So the point on the enlargement will be 2 squares across. Now vertically check the distance. Here vertically we have 5 squares. Multiply it by the scale factor. 5 times half is 2.5. So vertically you will have 2.5 squares. 2.5 squares means full 2 squares and half of a square. So vertically check 2.5. We have 1, 2 and half of another square, that is the middle point. So this is the point on the enlargement. Now to get the third point, we are going to follow the same step. Check the distance from the center of enlargement to the point there. As you can see, across we have 6 and up 2. Now multiply the distance with the scale factor. So if you have 6 squares, multiply it by the scale factor half, and vertically we have 2. So multiply it by half. 6 multiplied by half is 3. So the same point on the enlargement will be 3 squares from the center here, across 3 and up 1, because 2 times half is 1. So these are the vertices of the enlargement. Now you can fill in to get the shape. Now this is the enlargement of the triangle by scale factor half. As you know, scale factor half means your image will be half the size of the object. Now check object. If you check this length, object has 2 squares. What is half of 2? 1. So the same length has 1 square in it. Now here is a question where you have a negative scale factor. As we have discussed earlier, negative scale factor means the image will be on the opposite side of the center of enlargement. Scale factor -2 means your image has to be twice bigger, but it will be in the opposite side of the center of enlargement and your image will be upside down. Okay, so again follow the same steps. This time our center of enlargement is 6,6. Identify the center. 6,6 means x value is 6, y value is also 6. So here this is our center of enlargement. Mark the point on the grid. From the center of enlargement, draw straight lines through all the vertices, same way. Now here you have to be careful when drawing the ray lines. If you have a negative scale factor 2, your image will be on the opposite side of the center of enlargement. So draw your straight lines to the opposite side of the center, like the same way here. Now identify a point on the object. Check the distance from the center of enlargement. Here to this point, if we check the distance from the center, we have across 1, vertically also we have 1 square. Now multiply it by the scale factor. Scale factor is 2. We are going to ignore the negative sign and multiply by the value 2. Now the distance we know 1 multiplied by 2 is 2. So across 2 squares, vertically also you will have squares. Now since we have a negative value, we are going to take the distance to the opposite side. So from this point to the point here, to the right we had 1 square, multiplying by 2 it gives you 2. So we are going to take 2 squares to the left since we are having a negative scale factor. So to the left 2 squares, and vertically 1 multiplied by 2 is 2. So to downwards we are going to take 2 squares because the scale factor is negative. This is where the same point on the enlargement is going to be. Now we are going to follow the same steps to draw the remaining vertices of the object. Identify a vertex. Check the distance from the center of enlargement. Now from the center of enlargement to the point here, we have across 3 and vertically we have 1 square. So multiply it by the scale factor. Scale factor is -2, so 3 times 2 is 6. To the opposite side you are going to take 6 squares, and upwards we had 1 multiplied by 2 gives you 2. Since -2, downwards we are going to take 2 squares. So this is where the same point on the enlargement is going to be. Now follow the same process to get the third vertex. Check the distance, multiply it by the scale factor. Here it is across 1 square and vertically upwards we have 2 squares. So 1 multiplied by 2 is 2. So to the opposite side we are going to take 2 squares, and vertically upwards we have 2 squares to that point. 2 multiplied by 2, that is the scale factor, is 4. Since it is negative, now downwards we are going to take 4 squares. So this is where the same point on the enlargement is going to be. Now join the points to draw the shape. So this is an enlargement by the scale factor -2 from center 6,6. As you can see, our enlargement is twice bigger, but it is on the opposite side of the center of enlargement since we have a negative scale factor. Now our next part of the lesson is describing enlargements. To describe any enlargement, you will have to write 3 pieces of information. First one, you have to, as the first information, you have to state that it is an enlargement. Now how do you know if the transformation given is an enlargement? It is very easier because enlargement is the only type of transformation where the size of the object changes. So if you check the size of the object and the image, if the size is different, then you can say it is an enlargement. And the second information you have to write is scale factor. As the third one, you have to write the center of enlargement. Here is an example where you have to describe the transformation that maps A onto B. A onto B means your object is A and the image is B. From A to B, you have to describe the transformation here. To describe any transformation, first you have to state which type of transformation it is, whether it's a translation, reflection, rotation or enlargement. So state the type of transformation. Here we can easily see that it is an enlargement because the size of the object has changed here. So state that it is an enlargement. Now as the second information, you have to write the scale factor of the enlargement. As we know, scale factor means how many times the object has been enlarged. Sometimes the image, the size of the image might be smaller than the object. In that case also, you have to write that it is an enlargement, because in math, even if the size is smaller or bigger, we write it as an enlargement. Now after stating that it is an enlargement, for the second information you have to write the scale factor of the enlargement. As you know, scale factor means how many times the object has been enlarged. To get the scale factor, identify two corresponding sides. Two corresponding sides means if we take this side of the triangle, you have to take the same side on the image. Now if this is the side we are taking, the same side on the image is here. So we say these are corresponding sides. Now check the length of these two corresponding sides. We check the length here, we have 2 squares. Now on the image, the same side has 4 squares. Now check how many times this side has been enlarged. That will give you the scale factor. Now if you have 2 here and 4 here, check 2 times which value gives you 4. 2 times 2 is 4. That means our scale factor is 2. To be sure of your scale factor, you can check another side. Now to check if your scale factor is correct, you can check another side. If we take this side here, we have 3 squares in it. Now the same side on the image, on the enlargement, we have 6 squares. Now 3 multiplied by which value gives you 6? It is 2. So now we are sure that our scale factor is 2. So you can write scale factor 2. Now for the third point, you have to write the center of enlargement. To find the center of enlargement, you have to draw straight lines through the corresponding points or corresponding corners. So you can identify the corresponding vertices, that is corners. If you take the point here, you have to take the same point on the image, that is the point here. So through these 2 points you have to draw straight lines. You have to use ruler when drawing these lines. So through those 2 points, draw an accurate straight line. Now the same way, identify another pair of corresponding points. Now if you take the point here, the same point on the image is here. Through these 2 points, draw another straight line. Follow the same step for the remaining points. Now when you draw straight lines through the corresponding vertices, you can see all these straight lines will meet at one point. In this case, these 3 lines meet at here. So the point at which all the straight lines meet is the center of enlargement. Now here the center of enlargement, x coordinate is 1, y coordinate is 0. So our center is 1, 0. Now how to describe fully this transformation, how to write the statement is, you can write that it is an enlargement by the scale factor 2 from the center 1, 0. To describe an enlargement in your exam, you will have 3 marks, that is to write these 3 informations, 1 mark for enlargement, 1 mark for scale factor and the other one for center of enlargement. That is all about enlargements in IGCSE. Now let's see what we have discussed in today's class. We have discussed that enlargement is a type of transformation that changes the size of an object. The shape of the object stays the same, but its size is going to change. And the center of enlargement determines the position of the enlargement, and the scale factor determines the size of enlargement. If you want to practice more questions on this topic, go to your exercise book, page 569. Try questions on exercise 23.4. That's all for today. I hope we will meet soon with another topic. Please stay safe and study smart. Thank you.